We're going to continue chapter 3 and focus today on graphing linear equations in slope-intercept form. So last lesson we graphed in standard form by finding the intercepts. Now we're going to be graphing in slope-intercept form. So first thing that you need, and there's a bunch of stuff to write down, is understanding what the slope is. The slope of a non-vertical line passing through the points x1, y1, and x2, y2 is the ratio of the rise to the run. So it's your change in y over your change in x. So what do we want to write down here? We want to make sure that we have down everything here. What is slope? Okay, and there's a couple ways that you can think of slope. You can think of it as the rise over the run. What does that mean? That means the change in your y values over the change in your x values. So if you're given a graph here, think about how much are you going up or down, and put that over how much you're going to the left or to the right. So we think of a slope as change in y over change in x, and then most importantly, okay, when you're given 2 points, you want to think of the slope as finding your y2 minus your y1, aka your change in your y, over your x2 minus your x1. Sometimes you'll see it written as delta y over delta x. Delta is the Greek letter, kind of looks like a triangle. So when you see delta y, that means the change in the y values over the change in the x. When the line rises from left to right, the slope is positive. And when the line falls from left to right, the slope is negative. So always look at your answer and make sure that it makes sense by looking at the graph. If your graph is going up from left to right, that means your slope should be positive. If your graph is going down from left to right, then your slope should be negative. So let's take a look at these, okay? They've drawn arrows in. I'm actually going to use my own arrows because I always think of things as going from left to right, and this is kind of written a little bit weird for me. So I'm starting at this point right here at -3, -2. And I want to get to 3, 2. So how much am I going up? I'm going up 1, 2, 3, 4. So I went up 4. And then I went over to the right, 1, 2, 3, 4, 5, 6. So I went right 6. So it's your up, down over your left, right. So I went up 4. So my slope is 4. Over to the right 6, so 4 over 6, or 2/3. We can simplify that fraction. So my slope is 2 over 3. One thing to keep in mind when you're dealing with slope, okay, up and right are positive. And make sure you write this down. Down and left are negative. Okay? So if we look at our next example here, again, I'm not going to use the arrows they drew because I don't really like the way they've done it. So I'm going to draw my own in. I always go up or down first. So I'm going from this point to my next point. I'm going down 1, 2, 3. So I went down 3. So I know that's going to be a negative. So down 3 over 1, 2 to the right 2. Right 2 is a positive. So it's a positive 2. So my slope is -3 over 2. So all we're doing here is we're doing our rise over run. Your slope is equal to the rise over the run. If you wanted to, could you do your y2 minus y1 over x2 minus x1? Sure, you could, but if you're given a graph, I think it's easiest to just use rise over run. We'll do these examples in class. Now let's look at our second case where we're given a table. So if you're given a table and you're asked to find the slope, all right, one important thing to think about here is, could you graph this? Sure, you could graph this, but instead of graphing it, we're going to use our slope formula. y2 minus y1 over x2 minus x1. And they're giving us points here, okay? So if we look here, I'm going to make this my x1 value, and this my y1 value, and this x2, and this y2. So what is m equal to? M is equal to my y2 value, 14, minus my y1 value of 20, over my x2 value of 7, minus my x1 value of 4. 14 minus 20 is -6, over 7 minus 4, which is 3. We can simplify this, so the slope is just equal to negative 2. It doesn't matter which 2 points you choose. You can pick any 2 points you want. So if you wanted to use the points 13, 2 and 10, 8, you can do that. If you wanted to use 10, 8 and 4, 20, you can use that. So you can pick any 2 points to use as your y2 and y1 and x2 and x1. Doesn't matter. Let's look at our next example here. So again, I'll use the middle 2 points here. So x1, y1, x2, y2. So remember, change in y over change in x. So my change in my y values, 2 minus 2, over my change in my x values, which is 3 minus 1. So I end up getting 0 over 2, which is perfectly fine. Okay? That just means my slope is equal to 0. Okay, 0 in the numerator is definitely allowed, and we have a slope equal to 0. And we'll talk about what type of line that ends up being. Your third example, something else happens though, something interesting. So again, here, this time I'll use my bottom 2 points because it doesn't matter. x1, y1, x2, y2. So I have 9 minus 6 over negative 3 minus a negative 3. Well, a negative minus a negative in my denominator is just going to become plus. So I have 9 minus 6 over negative 3 plus 3. Now I have 3 over 0. 0 in the denominator is not allowed. When you have a 0 in your denominator, your slope is undefined. So we don't want to just leave our answer as m equals 3 over 0. We want to write that we have an undefined slope here. So notice the difference between B and C. In B, my 0 is in my numerator. That's perfectly fine. That means my slope is equal to 0. In C, my 0 is in my denominator. That means my slope is undefined, and there's a difference between those. So speaking of those differences, here's what we have. And this is an important thing to have a quick sketch in your notes. So obviously, if our line is rising from left to right, we have a positive slope as seen in our first example here. We have a negative slope here when my line is going from down from left to right. But these are the two things. A horizontal line has a slope equal to 0. So a horizontal line has a slope equal to 0. This is when we have 0 in the numerator of our slope. A vertical line has an undefined slope. So remember, horizontal lines have the equation y equals a number. Vertical lines have the equation x equals a number. So when you have that vertical line, say x equals 3 or something like that, your slope is undefined. Horizontal lines, your slope is 0. Those are the important things here. And there's a difference between a slope of 0 and a slope that's undefined. So make sure that you're aware of that. Slope-intercept form, very important that you know what slope-intercept form is. Slope-intercept form is of the form y equals mx plus b. Okay, the slope of the line is m, and the y-intercept, where it crosses the y-axis, is b. So we see an example here. Notice that your y-intercept is at the point 0, b. Okay, and this value that's next to the x, that's our slope. But in order for something to be in slope-intercept form, it needs to be y by itself, y equals mx plus b. So let's look at some examples here, where we're asked to find the slope and the y-intercept of the graph. So in A, it's already in slope-intercept form. So our value next to the x, remember, y equals mx plus b, is slope-intercept form. M is the slope, and then b is your y-intercept. So my 3 is my slope here, so I know m, my slope, is equal to 3, or 3 over 1 if you want to think of it as a fraction. And then your y-intercept, which is your b value, is equal to -4, and as a point, It's the point 0, comma, -4. Now, let's think about b. b is y equals 6.5. So in your head, you should be thinking this is a horizontal line because it's just y equals a number. So my slope of a horizontal line, if you want to think, this is really like y equals 0x plus 6.5. It's the same thing. So your slope, m, is just going to be equal to 0 here. What's the y-intercept? B. Your y-intercept is the point is 6.5, or it's the point 0, comma 6.5. Now in C, you must get y by itself first. So before you can determine what the slope and the y-intercept are, we have to get that y value by itself. So I'm going to start by adding 5x to both sides. Now, don't forget I have that negative sign, so negative y is equal to, I'm going to write it with my x first, 5x minus 2. Now, I have to divide by -1, so I'm going to divide everything by -1 because I really have a -1 in front of that y. So I'm going to get y equals -5x plus 2 as my equation in slope-intercept form. Now, just identify the slope and the y-intercept. The slope is what's next to the x. So your slope is -5. Your y-intercept, I'm going to write it as a point, is the point 0, comma 2. And there's your answer. But if y is not by itself, you have to get that y value by itself first before you can go ahead and determine what the slope and the y-intercept are. Let's graph this now, okay? It's very important that you're able to graph by hand. Yes, do we have the luxury of having Desmos? Sure, but you need to be able to graph this by hand. So you have 2x plus y is equal to 2, and we want to graph it using y-intercept, slope-intercept form. So we got to get y by itself. So we're going to subtract that 2x from both sides. And you're going to get y equals -2x plus 2. So let's identify what the slope and the y-intercept are. The slope is -2, or -2 over 1. Your y-intercept is at 2, or the point 0, comma 2. Make sure you write this down. When you have a positive slope, okay, and we talked about this before, you can move either up and right or down and left when you're graphing. When you have a negative slope, you can either move up and left or down and right. Okay, so you have to know the movement when you're dealing with the type of slope that you're doing. Now, y equals mx plus b. So you begin with b and you move with m. So we're going to begin at our y-intercept of 0, comma 2, which is right there. Now, we're going to move with m. So our slope is negative, which means I have two options. I can go up and left, or I could go down and right. I'm going to do both things. So I'm going to go up 2, 1, 2, to the left 1. I'm going to go up 1, 2, to the left 1. Or I can go down and right. So down 2, right 1. Down 2, right 1. And now draw in your line, and here's your point, or here's your line rather. They also asked us to identify the x-intercept, where it crosses the x-axis, which is right there. So your x-intercept here would be at the point 1, comma 0. But it's important when you're graphing that you're using the slope and the y-intercept to graph. I want to do one more example of graphing, and then we'll look at the last example. So let's graph number 9. I know it's part of the try these. We'll do the other ones in class. So in this particular graph here, our slope is 4, or 4 over 1, and our y-intercept is -4, or the point 0, comma, -4. So I'm going to begin with b at 0, -4, and I have a positive slope here. So my slope is 4 over 1, so I'm going to go up 1, 2, 3, 4, and over to the right. Positive slopes, up and to the right, or down and to the left. So up 4, right 1, or I can go down 1, 2, 3, 4, and left 1, and then just draw on your line. Okay, so make sure you're comfortable with how to move in terms of those things there. Let's go back and look at our last example here. So in our last example, it says a linear function g models the relationship in which the dependent variable, remember your dependent variable is your y, so this is our y, increases 3 units for every 1 unit the independent variable, x, increases. Graph g when g of 0 equals 3, identify the slope and the y-intercept. So we're combining a bunch of things here. We know g of 0 equals 3 is in function notation, and that means that when my x is equal to 0, my y is equal to 3. So this is giving me the point 0, comma 3, which is my y-intercept. So I know my y-intercept is 0, 3, and I can go ahead and I can plot that. Now, what it's telling me is it's saying, okay, the dependent variable, aka your y, increases, so my y, delta y, increases 3 units for every 1 unit that my x increases. So my change in y is 3 for every 1 unit of x. So 3 over 1 is my slope. I can use that 3 over 1 to create more points, and it's a positive 3 over 1. So I can go up 1, 2, 3 to the right 1. I can go up 1, 2, 3 to the right 1, or I can go down 1, 2, 3 and to the left 1. And I can create my line. The final thing it asks is what is the x-intercept? So we can look at the graph here. We see that the x-intercept is right there. So I know that my x-intercept is at the point -1, comma 0. So this important thing, or the tricky part here, is being able to interpret what that the words are actually saying here and understanding function notation. Once you can get that part down, it's not so difficult to actually graph this. We'll go to more examples in class. See you then, guys.